You know what's wild? Every single photo on your phone right now is lying to you. Not in some conspiracy theory way, but in a very real, very clever way that's been happening since the 1,990 seconds. And you've probably never even thought about it. Here's what I mean. Pull out your phone right now. Look at your photo library. You've got what, 1,000 photos? 2,000? Maybe 5,000. If you're like my friend who takes 17 pictures of the same sunset trying to get the perfect one. Now here's the thing that might blow your mind. Each of those photos, they're not actually showing you everything the camera saw. They're showing you a carefully edited version. A version that's been strategically destroyed and rebuilt. And your brain has no idea. Think about it this way. A single uncompressed photo from your iPhone could be 30 megabytes. That's massive. But when you look at it in your camera roll, it's maybe 3 megabytes, sometimes less. Where did the other 27 megabytes go? They disappeared, deleted, gone forever. And yet the photo looks basically the same. How is that possible? How do you throw away 90% of something and have it still look complete? That's what nobody talks about when they say JPEG. Everyone knows what a JPEG is, but nobody actually knows what's happening behind the scenes. Nobody knows about the brilliant psychological trick that makes the whole thing work. In the next 15 minutes, you're going to understand something that changes how you see every image on the internet. You're going to learn why some photos look crisp and others look weird and blocky. And you're going to realize that the internet as you know it, Netflix, Instagram, literally everything only exists because someone figured out how to exploit a quirk in your eyeballs. Let's get into it. So here's the problem we're actually solving, and it's bigger than you think. Picture this scenario. It's 1,995. You're trying to email your friend a photo of your new puppy. Cute, right? Except that photo is 8 megabytes. And you're on dial-up internet. You know what 8 megabytes takes on dial-up? About 45 minutes to send one picture of a puppy. Now imagine you're trying to build a website with images, or share vacation photos, or do literally anything with pictures on the internet. It's basically impossible. But here's where it gets interesting. The problem isn't just about internet speed. It's about storage too. Back then, hard drives were expensive. Like really expensive. You're paying hundreds of dollars for a gigabyte of storage. A single gigabyte. Today you can buy a terabyte for 50 bucks. But back then, one high quality photo could cost you actual money in storage space. So everyone's stuck. We've got this amazing new technology called digital photography. We can take pictures without film, we can view them on computers, we can theoretically share them across the world, but we can't actually do any of that because the files are too massive. And this matters because we're at this pivotal moment in history. The internet is just starting to become visual. The web is transitioning from boring text to the rich, image-heavy experience we have today. But it's all bottlenecked by this one problem. Images are too big. Everyone tells you the solution is to just make images smaller, shrink the dimensions, make them tiny little thumbnails. But that's not what people want. You want to see full-size, beautiful images that load fast and don't eat your storage. You want your cake and you want to eat it too. So here's what engineers figured out. And this is the part that changes everything. They realized something fascinating about human vision. Your eyes are liars. Well, not liars exactly. But they're very selective about what they actually pay attention to. And if you understand what your eyes ignore, you can throw that information away without anyone noticing. Think of it like this. Imagine you're looking at a photograph of a sunset. There's this gradient in the sky, right? It goes from deep orange at the horizon to lighter orange, then peach, then pale yellow. In reality, there might be 10,000 slightly different shades of orange in that gradient. But here's the secret. Your eye can't actually distinguish between most of those shades. You think you can, but you can't. Your brain is filling in the gaps. It's smoothing things out, it's making assumptions. And those assumptions are usually right. So what if we just stored the general idea of the gradient instead of every single precise shade? What if we said this area is generally orange, transitioning to yellow instead of cataloging every individual pixel? That's the core insight behind JPEG. It's not about making images smaller by making them lower resolution. It's about being smart about what information matters and what information is just wasting space. Now here's where things get really interesting. There's this pattern I call the detail paradox. And once you understand it, you'll never look at images the same way. The detail paradox is this. The human eye is incredibly good at detecting edges and contrasts, like ridiculously good. If you've got a photo of a person standing in front of a wall, your eye immediately locks onto that boundary where the person meets the wall. That edge is crucial. Your brain needs that information to understand what you're looking at. But you know what your eye is terrible at? Detecting small variations within smooth areas, like the exact shade of someone's forehead, or the precise color of the sky, or the subtle texture of a painted wall. Your eye just doesn't care that much. So JPEG exploits this. It keeps the edges sharp. It preserves the contrasts. But in the smooth areas, it gets lazy. It simplifies. It throws away detail you weren't really seeing anyway. Here's how it actually works. And this is where the magic happens. When you save a photo as a JPEG, it goes through this brilliant process. The image gets divided into tiny 8 by 8 pixel blocks, 64 pixels each, like a checkerboard across your entire photo. And each of those little blocks gets analyzed separately. The computer looks at each block and asks, what's actually happening here? Is it a smooth gradient? Is it a sharp edge? Is it a complex texture? And based on that analysis, it makes decisions about what to keep and what to toss. This process uses something called a discrete cosine transform. Don't let the fancy name scare you. Here's what it actually does. It takes those 64 pixels and breaks down the information into patterns, simple patterns and complex patterns. Think of it like music. Imagine you're listening to a song. There's a deep bass line, that's a simple, slow-moving wave. Then there's a high-pitched cymbal, that's a complex, fast-moving wave. A song is just a combination of different frequencies, right? JPEG does the same thing with images. It breaks down each little block into visual frequencies. Low frequencies represent the general color and tone. High frequencies represent fine details and textures. And here's the key. Just like in music, the low frequencies carry most of the important information. The high frequencies are just the subtle details. So what does JPEG do? It keeps most of the low frequency information, the general colors, the basic structure, but it starts throwing away high frequency information, all those tiny details that your eye barely notices anyway. But here's where it gets even more clever. There's this next step that happens, and this is where the actual data loss occurs. It's called quantization, and it's basically strategic rounding. Imagine you're measuring something, and instead of saying this is exactly 7.3847 inches, you just say, about 7 inches. You've lost precision, but the general idea is the same. JPEG does this with the frequency information. It looks at all those high frequency details and says, do we really need to store this down to 17 decimal places? Or can we just round it off and save space? And the answer is almost always, yes, you can round it. Your eye won't know the difference. The brilliant part is that JPEG lets you control how aggressive this rounding is. That's what the quality slider is when you save a JPEG. High quality means gentle rounding. You keep more detail. The file is bigger but looks better. Low quality means aggressive rounding. You lose more detail. The file is smaller but starts looking worse. It's like deciding how precisely to tell someone your weight. If you say 147.3 pounds, that's specific. If you say around 150, that's close enough for most purposes. If you say between 100 and 200, well, that's technically true, but not very useful. This matters because you're making this trade-off every time you save a photo. When you post to Instagram and it compresses your image, quantization. When you email a picture and it gets automatically resized, quantization. When Netflix streams a video to your TV, quantization on every single frame. Now here's the sneaky part. There's another pattern happening that most people never notice. I call it the color blindness trick, and it's wild. Your eyes have this quirk. You're way better at detecting brightness differences than color differences. like significantly better. You can distinguish between light and dark much more easily than you can distinguish between similar shades of color. JPEG uses this against you. Well, not against you, for you. But it feels sneaky. Before doing all that frequency stuff I just explained, JPEG converts the image from RGB, red, green, blue, into a different color space. It separates brightness from color information, and then it compresses the color information way more aggressively than the brightness information. Think about it like this. Imagine you're looking at someone's face in a photo. The contours of their face, the shadows, the shape of their nose, that's all brightness information. That's critical. But the exact shade of their skin tone, whether it's precisely this shade of tan versus that shade, your eye is much more forgiving about that. So JPEG says, let's keep all the brightness detail, but be lazy with the color detail. And you never notice because your eye works the same way. This is why JPEG is so good for photographs. Photos have smooth color gradients. They have areas where the color changes slowly. Perfect for compression. But you know what JPEG is terrible for? Text and sharp graphics. Because those have hard edges and sudden color changes everywhere, that's when you start seeing what we call compression artifacts. And here's where things go wrong. When people push this too far, let me tell you about Sarah. Sarah runs a small business selling handmade jewelry online. She takes beautiful photos of her products, but her website is loading slowly. So she downloads all her product photos and saves them as low-quality JPEGs to make the files smaller. Now her website loads faster. Great. But here's what Sarah doesn't realize. Every time she saves a JPEG, she's making that quantization happen. She's rounding off details. And if you save a JPEG as a JPEG again, you're rounding off details that were already rounded off. It's like making a photocopy of a photocopy. The quality degrades. Plus, Sarah's jewelry has sharp edges, shiny metal, intricate details, all the things that JPEG struggles with. So at low quality, her beautiful handmade necklaces start looking fuzzy. You can see these weird blocky patterns around the edges. The colors look washed out. The shine looks muddy. She's created what's called compression artifacts. And once they're there, you can't remove them. The data is gone forever. Now compare that to Marcus. Marcus also sells online. He also needs fast-loading images. But Marcus understood something important. He takes his photos in the highest quality possible. He keeps those originals safe. And when he needs a web version, he creates it fresh from the high-quality original. He uses PNG for images with sharp edges and text. He saves his JPEGs at medium-high quality, good enough for the web, not so compressed that artifacts appear. Marcus's website loads just as fast as Sarah's. But his products look crisp, professional. The compression is invisible because he understood the right balance. Notice how both of them wanted fast-loading websites, but only one of them achieved it without sacrificing quality? That's because Marcus understood the system. He knew that JPEG compression isn't just about making files smaller. It's about understanding what you're compressing and how much compression the image can handle. Here's what most people don't realize, and this is the part that changes everything. Compression isn't about cheating or cutting corners. It's about understanding how perception works. The people who created JPEG didn't just make files smaller. They studied human vision. They figured out what matters to your brain and what doesn't. They built a system that plays to the strengths of your eyes while hiding the weaknesses. It's not actually about technology at all. It's about psychology. The most brilliant compression algorithm in the world wouldn't matter if it threw away information your eye actually needed. But JPEG works because it throws away exactly the information you don't need. These patterns aren't some advanced computer science wizardry. They're predictable, logical decisions based on how humans actually see the world. Once you understand the detail paradox and the color blindness trick, you can make smart choices about when to use JPEG and when to use something else. So here's what we've uncovered. Images aren't just data. They're crafted experiences designed to match how your brain works. JPEG divides images into tiny blocks, analyzes the patterns in those blocks, throws away high-frequency details your eye won't miss, rounds off color information more aggressively than brightness, and does it all in a way that's basically invisible to you. Remember the detail paradox? Your eye cares about edges, but not smooth areas. Plus, Plus, the color blindness trick, where you notice brightness more than exact colors. This all connects to why JPEG became the standard for photos everywhere. It exploited exactly the right quirks of human vision. The question isn't whether you should use compression. You have to. The internet couldn't exist without it. Your phone couldn't store thousands of photos, Netflix couldn't stream video, none of it would work. The question is whether you'll use compression intelligently, whether you'll recognize when you're looking at a photograph that can handle aggressive JPEG compression versus a graphic with sharp lines that needs PNG, whether you'll keep your originals and create compressed versions only when needed, whether you'll understand that quality slider and what it's actually doing behind the scenes, because now you know something most people don't. Every image you see online has been strategically destroyed and rebuilt. Data has been thrown away, details have been eliminated, and yet it looks fine. It looks complete. Because the people who built these systems understood your eyes better than you do. So next time you save a photo, ask yourself, am I choosing the right format for what this image actually is? Am I keeping the original? Am I compressing smart or just compressing hard? Because once you see how compression really works, you can't unsee it. You'll start noticing artifacts in heavily compressed images. You'll spot the blocky patterns in low-quality JPEGs. You'll understand why some images look crisp and others look muddy. You now have the insight that makes you see images differently, not just as pictures, but as carefully constructed illusions designed to trick your eyes in the smartest way possible.